Hi there, this is the presentation of Intelligent Mobile Manipulator using Deep Learning. This is a part of Pioneer Project Title by Muhammad Fikri bin Muhammad Azli and also Siti Nurfahim binti Abdul Aziz. We were supervised by Dr. Yassin Mustafa, and we are from Kuliah of Engineering, International Islamic University of Malaysia, and we are part of Google Track Technologies. Now, let us proceed with problem statement.
We have identified problems regarding warehouse management technology. One of the problems that arise is the high-level cost and multitasking needs. Generally, a typical warehouse uses expensive equipment and employs a large labor force, which presents some challenges faced in warehouse management. Another problem that arises in warehouse is low productivity. This problem occurs due to inaccurate inventory while maintaining stock level. Therefore, automated system offer real-time and accurate information about stock level and composition.
Alright, moving on to the project background. Generally, this project is an extension design of two different robots. One is a hand robotic manipulator that is mounted on a mobile platform robot. It can perform pick and place tasks that can be done to a specific place, not only to the space nearby it. This project uses deep learning vision, where they rely on camera vision to make the decision autonomously. Hence, an image processing algorithm is introduced to achieve the objective of this project. The image processing algorithm will further develop in TensorFlow, which part of Google Track Technologies. Let us proceed with the objectives of this project. As you can see here, the first one is to develop a vision-based mobile robot manipulator equipped with camera. And the second one is to design a hand robotic manipulator that is able to perform pick and place tasks. And the third one is to identify a suitable algorithm for mobile robot manipulator using deep learning feature. And the last one, to test and verify the algorithm on mobile robot manipulator. Let us proceed with the methodology. Basically, we're dividing the methodology into two parts. The first one is robot mobile platform itself, and the second one is pick and place robot manipulator.
The hardware design for the mobile platform includes the selections of the sensors, actuators, and microcontrollers. The microcontrollers that will be used for mobile platforms is the Arduino and Raspberry Pi. The image input will be captured using a webcam and will be perform image processing in a Raspberry Pi, and the robot motions will be controlled by using Arduino, as it will give a command to the drivers to actuate the DC motors after receiving data from the Raspberry Pi. For the actuators, we are going to drive the mobile robot using a 3 DC gate motors with encoders and motor drivers that will be used to control the speed and the directions of the wheels are MD30C. We are going to use motor drivers of MD30C because of its high peak current, which it can withstand 30 ampere for the mobile robot. So for this robot, also it will drive using a 3 Omni wheels configurations. So we decided to use Omni wheels because of its holomonic motion. The robot can move in any trajectory of a plane, and it can change its orientations simultaneously by using Omni wheels. For the software design, we are going to use a Python language and C++ language for performing the codes. So for the Python, we are going to perform image processing coding, while for the C++ language will be used to control the motions of the motors using Arduino IDE. So since our project are going to use camera-based vision, so we are going to use open source computer vision OpenCV library to process image data acquired from the camera vision. So this library will be perform a labeling and classification process using a features extraction from the image. For this mobile platform, we are going to divide the algorithm into two things, which are path planning algorithms and object detections algorithms. For the path planning algorithms, we are going to focus on floor segmentations, where these techniques are going to use image color segmentations, canny edge detections, region of interest selections, and half transform. So actually for these algorithms, we are focusing on detecting the color of the lane for the mobile robots to guide based on the lane detections. So for the object recognition algorithms, we are going to detect the obstacles, and from the objects detections, we can actuate the motions of the wheels to avoid the objects in front of the camera. So for these algorithms, we are going to use the combinations of features extractions and classifications. For example, like a pack of visual words, oriented fast and rotated brief ORB, and for the classification we are going to use a k-mean clustering and support vector machine SVM. So for these algorithms, actually there are two phases that are very important, which are training phase and also another one is a prediction phase. So the training phase is where the training images that will be trained by extracting the important features and descriptors, and these features will be compared with the test image. So in a prediction phase, the features and descriptors also will be extracted from the test image only, and then the classification can be performed by using by comparing the both features from the test image extracted from the test image, and also the features extracted from the training image in the training phase. So basically from this prediction phase, we can have the accuracy and the precision of the output, which can be calculated in this phase.
For pick and place robot manipulator in the hardware design, we decided to develop a 4 degree of freedom. Hence, we are using 4 actuators. The actuators that we are using is stepper motor, which is with the specification of 12 volt NEMA 17 together with TB6560 motor driver, with the feature and extension of to control the excitation current and also to control the microstep feature. So we designed all stepper motors to be located at the base instead of located at each joints. The reason is why, because we want to reduce the distribution weight and load across each arm, the first arm, the second arm, and at the gripper. Hence, we are only concentrating to lift up the object itself. To perform this kind of system, we are using belt and pulley system to drive the power transmission from motor to each joints. And for the end effector, we are using gripper. In this robot method, we are also using Arduino microcontroller to control all the output of the motors, and also we are using Raspberry Pi 3 to be execute image processing algorithm, and to integrate of these two different of Arduino and Raspberry Pi 3, we are using serial communication. For the software design, we are using Arduino IDE itself, where in this Arduino IDE we using programming coding to control all the stepper motor motion as the output. In this Arduino, we are using C++ language programming, and it will be different when using Raspberry Pi 3, where in Raspberry Pi 3 it is its own operation software, Raspbian, and in this Raspbian we are using Python programming language, and we are also using a TensorFlow, which is part of the Google Track technologies, and we are also using OpenCV, which is part of libraries that we use for image processing algorithm.
In conclusion, we managed to develop a mechanical design mobile robot manipulator, and we are also managed to identify the suitable algorithms and has been tested in Python simulation so that it can be implemented for the projects. And currently, we are still on progress to implement the real-time algorithms for the robots platforms.